In Kentucky alone, there are more beer kegs than people. You heard that right. Across the United States, the numbers are staggering. Americans drink more than 6.3 billion gallons of beer every year. That amount could fill 9,000 Olympic-sized swimming pools. No other alcoholic drink even comes close. And yet, it all comes from just 4 ingredients: water, barley, hops, and yeast. How can factories turn something so simple into billions of bottles that taste exactly the same? Beer is older than writing. Archaeologists have uncovered clay tablets in Mesopotamia describing brewing methods from over 5,000 years ago. European colonists carried the tradition to America in the 1600s. Early settlers brewed rustic ales in small taverns scattered along the East Coast. The true expansion began in the 1800s, when German immigrants brought lager brewing techniques. They founded breweries like Anheuser-Busch, Miller, and Coors, names still dominating shelves today. From baseball stadiums to backyard cookouts, beer became a cultural ritual. Even Prohibition in the 1920s couldn't erase it. The moment the ban ended, industrial breweries roared back with equipment designed for massive, uniform production. Every batch begins with grain. Trucks unload tons of barley into elevators rising higher than a house. Inside, barley is steeped in water for 2 days. The grains sprout just enough to activate enzymes that will later unlock sugars. Hot air kilns halt the growth, drying the malt and filling the air with aromas like toasted bread. Finally, the malt is milled into coarse grist. Precision scales measure every load because even a tiny error could shift the flavor of millions of pints. The grist flows into mash tuns, steel vessels large enough to resemble swimming pools. Hot water floods in, raising temperatures to around 150 degrees Fahrenheit. Enzymes break down starch into fermentable sugars. After an hour, the sweet liquid, called wort, runs off into lauter tuns. Spent grain is left behind, often recycled as cattle feed. The wort then enters kettles where it boils for over an hour. Hops are added, releasing bitterness, aroma, and natural preservatives. Steam clouds fill the air as copper domes roar. The wort is cooled rapidly through heat exchangers, dropping from near boiling to room temperature. Without this step, yeast could not survive. The liquid enters towering fermentation tanks, some holding hundreds of thousands of pints. Once yeast is pitched, sugar disappears and alcohol forms. Carbon dioxide escapes in a hiss, foam rising to the top. Fermentation lasts 5 days to 2 weeks, monitored by sensors tracking temperature and pressure. How long do you think yeast remains active inside these tanks before the beer is ready? Freshly fermented beer is called green beer. It contains alcohol but tastes rough and unfinished. Factories move it into conditioning tanks chilled near freezing. Over several weeks, flavors mellow and carbonation is balanced. Next, the beer is filtered through membranes fine enough to catch single yeast cells. Cloudy liquid becomes brilliant and clear. Technicians check samples daily. Alcohol percentage, color, and clarity must remain identical across every batch. Filtered beer flows into filling halls buzzing with automation. Bottles and cans move along conveyors in endless rows. Machines fill them at 1,200 bottles per minute, while caps and labels snap into place. Laser codes print freshness dates, and any underfilled or leaky containers are rejected instantly. Finally, cases are stacked, shrink-wrapped, and loaded onto trucks. What required weeks of brewing ends in seconds on the bottling line. Beer is measured in weeks. Whiskey counts in years. The bottle of whiskey in your hand may be older than you are. Indeed, some barrels wait 20, 30, even 40 years before they are ever tasted. Decades pass, yet the spirit remains untouched. Patience is not a choice. It is the very ingredient that defines whiskey. No machine can replace what oak and time create together. Today, more than 37 million barrels of whiskey are aging across the United States, according to the Kentucky Distillers Association. Join me inside a Kentucky distillery to witness how grain and fire are transformed into liquid history. Whiskey crossed the Atlantic with settlers in the 1700s. Irish and Scottish immigrants carried copper stills and recipes into the Appalachian frontier. Kentucky soil favored corn, and limestone filtered water gave cleaner spirit. The The drink grew so essential that a federal tax on it sparked the Whiskey Rebellion of 1794. Farmers resisted, showing this was not a luxury. It was survival. Prohibition in the 1920s nearly destroyed the craft. Yet after repeal, family distilleries returned, and American whiskey rose again as both cultural icon and global export. The journey starts with grain. Corn, rye, wheat, and barley arrive by truckloads, each tested for quality and moisture. Steel rollers grind kernels into coarse meal. It looks like golden flour, gritty and rough. This is the mash bill. Recipes are guarded. Rye brings spice, wheat softens, barley adds depth. Even a 1% shift changes the final flavor. From here, conveyors lift the grain meal into giant cookers, ready for the next stage. Inside the cookers, grain meal mixes with hot water. The thick slurry bubbles like porridge. After hours of cooking, the room smells like baked bread and cereal. The sweet mash is heavy, steaming, and ready for fermentation. The mash flows into vast tanks, some made of cypress wood more than a century old. Others shine in stainless steel. When yeast is added, the mixture comes alive. Foam rises, bubbles break, and carbon dioxide escapes in bursts. Heat builds quickly, so cooling jackets wrapped around the tanks protect the yeast. After 3 to 5 days, the sweet mash becomes distiller's beer, sour, cloudy, and holding 8 to 10% alcohol. Would you dare taste this sharp, unfinished liquid knowing it is only halfway to whiskey? From fermenters, the beer-like liquid is pumped into copper stills. Heat drives alcohol into vapor, leaving water and impurities behind. The vapor condenses into clear spirit at more than 120 proof. But clear spirit is not whiskey. Workers fill it into new oak barrels, charred black inside by open flames. Crackling fire leaves layers of charcoal and caramelized wood. Barrels are rolled into rickhouses, warehouses that breathe with the seasons. In summer heat, spirit expands into the wood. In winter cold, it retreats. With every cycle, color deepens and flavors of vanilla, spice, and smoke emerge. Years pass. Time becomes the silent worker no machine can replace. When the master distiller declares a batch ready, barrels are rolled out and sampled. Some become single cask releases. Most are blended from hundreds to guarantee a consistent profile. The spirit is diluted with pure water until it reaches 40 to 50% alcohol. Filters strain out flecks of char before bottling. Automated lines fill hundreds of bottles per minute. Caps are sealed, labels applied, serial codes stamped. Within hours, cases are stacked, wrapped, and shipped worldwide. Whiskey counts in decades. Coca-Cola is made in minutes. The formula for Coca-Cola is one of the most closely guarded secrets in the world. This recipe is kept inside a vault in Atlanta, protected as one of the most valuable trade secrets in history. Only a select few know it in full. Yet from that hidden formula comes the most familiar drink on Earth. More than 1.9 billion servings are consumed every single day, according to the Coca-Cola Company. So how does a syrup locked behind steel doors become billions of identical bottles racing off factory lines? Step inside the factory floor with me to uncover the answer. The story begins in Atlanta in 1886. Pharmacist John Pemberton created a syrup he sold at his local drugstore soda fountain. The drink was advertised as a medicinal tonic, flavored with coca leaf extract and cola nut. Customers loved the taste, and demand spread quickly. By the early 1900s, a businessman named Asa Candler turned Coca-Cola into a brand. He built a distribution network and marketed the drink as pure refreshment. Over the next century, Coca-Cola expanded worldwide. From World War II rations for soldiers to Olympic sponsorships, it became a global symbol of America itself. Every bottle of Coke begins with syrup. Inside a secure mixing room, workers combine sugar, caramel color, caffeine, and natural flavors. The exact combination, known as Merchandise 7X, is a trade secret. Ingredients arrive under strict tracking, and recipes are coded so only partial formulas are visible to any single employee. The result is a dark, concentrated syrup. On its own, it is far too sweet and strong. Only when diluted with purified water does it become recognizable as Coca-Cola. Water is the foundation. Factories spend more time treating water than mixing syrup. Incoming water passes through multi-stage filters, carbon beds, and reverse osmosis systems. These steps strip away chlorine, minerals, and any trace impurities. Technicians monitor taste, clarity, and pH constantly. If the water fails, the entire batch is scrapped. Consistency matters. A Coke in Los Angeles must taste identical to one in London. Only once the water meets standards does it blend with the syrup in exact ratios. The blended liquid now receives its defining feature: fizz. Carbon dioxide is injected under high pressure, dissolving into the drink. Each plant calibrates pressure carefully, since temperature shifts can change bubble size. A Coke poured too flat loses its bite. One overcarbonated foams uncontrollably. Industrial systems control both variables to the decimal. Which do you think tastes better? Coca-Cola from a glass bottle, a can, or a plastic bottle? The finished beverage moves to filling halls. Stainless steel machines line up bottles and cans in perfect rows. At speeds exceeding 2,000 containers per minute, valves inject Coke with astonishing precision. Caps snap on instantly, cans are sealed airtight, and labels roll into place. Sensors scan every container. Underfilled or missealed products are rejected automatically. In seconds, perfect packages are ready for boxing. Cases of Coke are stacked onto pallets, shrink-wrapped, and loaded onto trucks. From there, distribution spans the globe. Supermarkets, vending machines, gas stations, and restaurants receive deliveries daily. Coca-Cola delivers instant fizz. Coffee delivers a slower ritual. The smell of fresh coffee is the alarm clock of millions of Americans. Long before emails or traffic, steam rises from mugs in kitchens, diners, and office break rooms. That ritual defines the start of the day. Yet the journey from green beans to that morning cup is far from simple. Each sip carries the work of farmers, roasters, and factory lines spanning continents. According to the National Coffee Association, the United States consumes more than 3.3 billion pounds of coffee every year. The path from seed to sip hides a process more complex than most people ever imagine. Coffee's story begins in Ethiopia. Legend says a goat herder noticed his animals grew energetic after eating red berries. By the 15th century, the drink spread through the Middle East, then into Europe. Coffee houses became centers of trade, politics, and debate. In the 1600s, colonists carried the beans to America. By the 20th century, brands like Maxwell House and Folgers turned coffee into a household staple. Today, global giants like Starbucks and Dunkin' have reshaped it again, turning a centuries-old brew into a daily American ritual. Coffee begins as a fruit. On farms across Latin America, Africa, and Asia, ripe cherries are picked by hand or machine. The cherries are washed, pulped, and separated. Bright red skin is removed, exposing the raw green beans. Factories then sort beans by size, density, and defect. Every shipment is graded because a single bad lot could ruin an entire batch. Only the best beans move forward to roasting plants. Fresh beans contain high moisture. Left untreated, they would spoil quickly. Once dried to about 11% moisture, beans are stored in jute sacks or silos. This stability allows them to travel thousands of miles by ship before roasting. By the time they arrive at an American factory, beans are green, dry, and ready for transformation. Roasting is where coffee becomes coffee. Industrial roasters tumble beans through drums, heated between 370 and 540 degrees Fahrenheit. As heat rises, sugars caramelize, and proteins trigger the Maillard reaction, producing deep aromas. Light roasts preserve acidity, while dark roasts develop smoky bitterness. Each profile demands precise timing. Seconds too long can burn thousands of pounds. Viewer question: do you prefer your coffee roasted light and bright, or dark and bold? Freshly roasted beans are cooled quickly to halt reactions. They are then ground to different sizes depending on the product. Factories use precision grinders to create coarse grounds for French press, medium for drip machines, and fine powder for espresso. Vacuum-sealed bags and one-way valves keep oxygen out while letting gases escape. Without this packaging, roasted coffee would lose its aroma within days. Ground coffee is boxed for retail, while whole beans are sealed for cafes and specialty shops. Beyond retail, some factories produce ready-to-drink coffee. Large brewers extract concentrate under controlled pressure and temperature. The concentrate is chilled, mixed with milk or flavorings, and bottled on aseptic lines. Cans of cold brew or sweetened lattes roll off conveyors by the thousands. From instant granules to single-serve pods, the same bean takes many forms. Trucks then deliver coffee nationwide, from supermarkets to gas stations to cafes. Every morning cup begins with this global system: farmers harvesting, ships moving, factories roasting, and machines packaging. Everyday drinks carry extraordinary stories. Beer, produced in weeks, shows how factories harness living organisms into predictable routines. Whiskey, aged for decades, reminds us that patience can shape flavor more than any machine. Coca-Cola reveals the power of secrecy and speed. From a guarded syrup to billions of identical servings, it proves precision can operate at breathtaking scale. Coffee ties it all together, a ritual as old as history, but still engineered through farms, ships, and factories to meet the demands of modern life. Each product looks simple on the table. Yet behind every glass or cup stands an industry of farmers, chemists, machines, and centuries of tradition. Do you want to see more hidden processes inside the foods and drinks you know best? Subscribe to Captain Discovery and turn everyday habits into stories worth sharing.